Today I'm going to explain problems on super loop analysis. As you're already familiar, what is a super loop now? When the current source is existing between the two loops, then it is called as a super loop. So note down the problem. So you can write a circuit like this in the exams. If they ask a circuit like this, this is your dependent current source, and this is we can call as a 2I, and here that is connected to one resistor, and here it is connected another current source, and here they connected a one resistor like this, and from here to here there will be like this, and this is our 12 amps, and this is 28 ohm, and this is the current, it is I, and this is 2I, and this is our 8 ohm, and this is 4 ohm. In the exam, they can ask the question like this: find the current I in 28 ohm resistor by mesh analysis shown in the figure. So assume the loop current. This is the one loop current that I am assuming as a I1, and another loop current for this loop I am assuming the current as I2, and this loop current I am assuming as a I3. So in this example, this current source, that is a dependent current source, is existing between loop 2 and loop 3. Therefore, this becomes a super loop. This is the super loop. The whole loop we can call as a super loop. This is our super loop in this diagram. That means when the current source is existing between the two loops, that is loop 2 and loop 3, therefore that whole loop we can call as a super loop. Now the current I1, it is in the same direction of existing current 12 amps, therefore we can directly write I1 is equal to 12 amps. And write a constraint equation. Here you have to write a one constraint equation. So after write a constraint equation, that is I2 is in the same direction of existing current 2I, therefore I2 is greater than the I3. So then what is the current flowing to this branch? That is I2 minus I3. I2 minus I3 is equal to 2I. But what is I here? Looking from the diagram, what is I? I is nothing but the current flowing through the 28 ohm resistor. That is nothing but your I. So here I is, we can write it as a I1 minus I2 because I1 is in the same direction of I. Therefore I1 is greater than I2. Therefore I, you can write it as I1 minus I2. That means this equations becomes I2 minus I3 is equal to 2 into I1 minus I2, because I2 is in opposite direction of I1. Therefore you can write it as I as I1 minus I2. So this becomes I2 minus I3, that is equal to 2I1 minus 2I2. That is 2I1, this is minus 3I2, and this is becomes a plus I3 is equal to 0. Already we know the value of I1, that you can substitute 2 into 12 minus 3I2 plus I3 is equal to 0. This becomes minus 3I2 plus I3 is equal to minus 24, or you can write it as 3I2 minus I3 is equal to 24. Call this equation as a 1. Next, you can apply the KVL for the super loop. So what is a super loop now? This whole what I have marked in the red color now, that is a super loop. Then apply the KVL for that loop. Then we can write the equation like this. This is 4I3 plus 8I2 plus 28 into I2 minus I1. I2 minus I1 is equal to 0. This is 4I3 plus 8I2 plus 28I2 minus 28I1 is equal to 0. But I1 is equal to 12 amps. Substitute that value. 4I3 plus 8I2 plus 28I2 minus 28 into I1 is 12 amps. That is equal to 0. This becomes 36I2 plus 4I3. 4I3 is equal to 28 into 12. This becomes 9I2 plus I3, that is equal to, write it as a 84. Call this equation as a 2. Now you can solve the equations 1 and 2. Then we can write it as I2 is equal to 9 amps and I3 is equal to 12 minus 9, that is equal to 3 amps. So therefore, what is the current flowing through the 28 ohm resistor means? That is I is equal to I1 minus I2. That is the current flowing through the 28 ohm resistor. So that is current flowing through the 28 ohm resistor, that is equal to I1 minus I2. I1 minus I2. Okay. So that is equal to I1 is 12 and I2 is 9. Therefore, this is 3 amps. Let's note down the another problem. So the problem is like this. This is the one resistor and another resistor. This is another resistor here. And here it is connected a resistance like this, and it is connected here one current source like this, and here there will be one voltage source, positive, negative, and this is for positive, negative, and this is 2I1. It is connected like this, and this is for 3 volt, and this is 1 ohm, and this is a 1 ohm, this is 2 ohm, and this is a 2 ohm, and this is a current is 4 amps, and here that current is flowing, it is, that is I1. In the exam they can ask the question like this: find current in 2 ohm resistors by mesh analysis shown in figure. There will be here 3 loops. Assume the loop current. We can assume the loop current like this. This is the one loop current. So I am assuming this loop current as I1, and this is loop current, it is I2, and this loop current I am assuming as a I3. So in this example, there will be a 4 amps current source is existing between the loop 2 and loop 3, and therefore this is the super loop. So this becomes a super loop. So this is the super loop. This becomes a super loop. This is your super loop. So now apply the KVL for the loop 1. So apply KVL for the loop 1. Apply KVL for loop 1. Then we can write the equation like this: 1 into I1 plus 2 into I1 minus I2 because I2 is in opposite direction of I1. Therefore, you have to write I1 minus I2 minus 3 that is equal to 0. This becomes 3I1 minus 2I2 is equal to 3. So call this equation as a 1. Now apply KVL for the super loop. Apply KVL for super loop. When I apply the KVL for the super loop, we can write the equation like this. 1 into I2 plus 2 into I3 plus 2 into I1. This is a 2I1 plus 2 into I2 minus I1. I2 minus I1 is equal to 0. Simplify this is I2 plus 2I3 plus 2I1 plus 2I2 minus 2I1 is equal to 0. The 2I1 but 2I1 it cancels. Okay. Then we can write it as 2I2, that is 3I2 plus 2I3, okay, is equal to 0 is equal to 0. This call this equation as 2, and you can write one constant equation. Then that constant equation is 4 amps is same direction of I3, therefore I3 is greater than the I2. Therefore you can write it as constant equation as I3 minus I2 is equal to 4 amps. This you call this equation as a 3. Now you can solve the equations 1 and 2. Solve the equations 1 and 2. Then we can write, so I1 is equal to, after solving the equations, we can write it as I1 is equal to minus 0.066 amps, and then we can write I2 is equal to minus 1.6 amps, and then I3 is equal to 2.4 amps. He has to find out what is the current flowing through the 2 ohm resistor, but in this problem there will be a 2 ohm resistance are there. Therefore current flowing through the 2 ohm resistance is current on 2 ohm, that is equal to I3, that is equal to 2.4 amps. Another resistor is, in that resistor current flowing to that resistor I2 is equal to I1 minus I2, that is I1 is minus 0.0666 minus I2, that becomes a plus 1.6, so that is equal to 1.534 amps. 1.534 amps.